Greetings, I'm Squared, and this is a tutorial on finding and graphing the inverse. In the first tutorial we just did some lines, graphed some lines. This is a parabola and this is a square root function, so it's a little bit different, step up. So there's two ways to do it. One way is you can actually find the inverse. Remember, we find the inverse by switching x and y and solving for y, and then graphing the inverse in the function. And the other way to do it is just to make a table of points and then graph those points and then graph the other points of the inverse. It's really important to be able at this level to recognize what shape this is. If you don't know that this is a parabola and you don't know that this is a square root function and that it looks like this, kind of like a sideways half a parabola, you really need to know that, or this chapter is going to be kind of difficult. So first of all, if I know this is a parabola, I know that normally my parabola would start at 0, 0, but that this minus 4 shifts my vertex to the right 4, and that this plus 3 shifts my vertex up 3. I also know that there's nothing in front of this function, so that in that case it would be a if you remember your transformation, so it doesn't get skinnier or fatter. So I know that if I go over 1 up 1 on both sides, that I have 2 more points of my parabola. And because it's positive out front, I know it opens up. I know that if I go over 1 more and then up 3 more, 1, 2, 3, that I have some points. Now if you're not sure about that, you can always make a test value, a table of values. So if I put a 2 in, 2 minus 4 is negative 2, squared is 4, plus 3 is 7. So if I'm over 2, I'm up 7. And you'll see how that works. So if you didn't know how to do that, it's okay to not know how to do it. I don't know if your teacher allows you to use graphing calculators. You could always put that in your graphing calculator and go to the table. But it's a nice, handy little trick to know. And then you don't have to do so many values, okay? Because we could put a 2 in, and what we get? A 7. Then when we put a 3 in, we get 9 minus, when we put a 3 in, we get a 1. So we get a 1 squared is a negative 1. Negative 1 squared is 1, and plus 3 is 4. So when we put a 3 in, we got a 4. See that? 1, 2, 3, up 4. When we put a 4 in, this becomes 0, so we're just at 3. And we could continue to do that. And so on this side, we are still going up, but then our values kind of are symmetrical. So this is our value of f. These are our table of values for f of x, but now we need to find the inverse. Well, one way to do that is to just switch all of these points. So we'd have 7, 2. So we'd go over 7 and up 2. And then we'd go over 4. 1, 2, 3, 4. And up 3. And then we'd go over 3. And up 4. And over 4. And up 5. And over 7. And up 7. And you kind of see that it looks like this. And remember, our goal is for them to always be symmetrical about that line x equals y, and you see that that is right there. But let's just real quick find the inverse function. Now you'll notice, in the book asks you to do stuff like this, but when you go up in knowledge, you'll know that the vertical line test is always used to figure out if something's a function. So in our black graph there, the f of x, it's a function because the vertical line passes. But the horizontal line test is used to say if it's a one-to-one function. The f of x does not pass the horizontal line test, which means it does not have an inverse. Well, we can still switch points and see that that happens, but we consider it not to have an inverse, and because this isn't a function. And the green one, the inverse, what we're calling it, it doesn't pass the vertical line test, so it's not a function. But over here, if you wanted to switch x and y, you'd get this. And then we minus 3 from both sides. We get x minus 3 equals y minus 4 quantity squared. And then to get rid of the squared so we can get y alone, just remember that's our goal, we square root. Whenever we square root both sides of an equation, we get plus or minus. So now we have this. And then we would end up with, I'm going to move, kind of switch sides here on you. We'd add 4 to both sides, so we get 4 plus or minus the square root of x minus 3. Now just real quick, if you put a 3 in there, let's just test it. If you put a 3 in there, you get a 0, the square root of 0, and 4 plus 0. So notice that when we went over 3, we were up 4, like that suggested. So just two ways to do it. Let's find the inverse first on this one. Hope that's not too confusing, but it can be a little bit. We're going to switch x and y first. And hopefully you remember how to get rid of a square root. Remember, just like addition and subtraction are opposites, multiplication and division are opposite operations, so are square roots and squaring. That's why we square rooted up here to get rid of the squared. To get rid of the square root, we square. So now we have x squared equals y minus 3 because these cancel. And then to get y alone, we simply add 3. So we get y equals x squared plus 3. So this is our inverse function. So this is a parabola, just moved up 3. And we can graph that. We can do a set of charts, a table of values. When you're doing square root table of values, I don't like to count by 1, 2, 3, 4. I like to count by whatever is going to make that a nice, perfect square inside the radical. So for example, I know I can't use anything less than 3 because that would make it negative. So I'm going to use 3 first because 3 minus 3 is 0 and the square root of 0 is definitely 0. And then I might use something that would get me a 1 inside. Well, what would get me a 1? What minus 3 equals 1? Well, 4 does. 4 minus 3 is 1 and the square root of 1 is 1. And then I'll jump up because the next one I want a 4 inside, and a 7 gives me a 4 inside. 7 minus 3 is 4, and I know that the square root of 4 is 2. And that's kind of how I like to do it. If we go more, it would be a 9, and that would take us off our little graph here. So I won't do any more, but let's graph that. So we know it's at 3, 0. And if you knew what the square root looked like, you would also know that that's moved left 0. And then you would go over 1 up 1, and then you go over 4. More up 2. Anyway, we're up to 7. 1, 2, 3, 4, 1, 2. I believe that's right. So that's our original function, or y. And then this would be our inverse function. And our inverse function, x squared plus 3, means we're up 3. Now I don't know if you just want to switch these. It makes it a lot easier. 0, 3, 1, 4, and 2, 7. So that was 4, 5, 6, 7. So it kind of looks like that. And notice if you just use a table, you don't see that parabola, the other part. And really you wouldn't want that in this particular one because you want them to be symmetrical. And if all you have on this one is that half of the parabola, then that's all you want on that one as well. And that is a little bit more about finding the inverses and graphing. Hopefully that was helpful. Good luck. M squared, signing out.